Hello everyone, welcome back. Today we are going to have practical examples of subnetting. In our previous lecture we had a discussion about subnetting, and today where we are going to understand how we can practically do subnetting. We will start from the class A. Class A is assumed the difficult one, and mostly people start from the class C that because that is the simple one, but I believe if you will understand the difficult one, so obviously you will do the easy one by yourself. Okay, so let's do the class A subnetting. I will take the example of the class A private IP address 10.x.x.x. Okay, let's first have the classful approach and then the classless approach. Okay, remember, subnetting is a classless approach. Okay, first the default classful or default approach. Like here we have 10.0.0.0. 10 is the prefix part. How do I know? From the default subnet mask. So this one is the network part and this is the host part. 10 is itself a network. Okay, we will not use here the formula 2 power n. Okay, because 2 power n is used in the default approach to find out the number of networks in a class. Okay, and 10 is already a single network, so we don't need to find the number of networks. Okay, and here this is the host. How many bits are host bits are is equal to 24. So if you want to find the number of hosts per this network, which is 10, 2 power 24 is equal to 16,7,216 minus 2 is equal to 16,214. This is the amount of host in this network 10. Obviously this is more than our requirements. I don't believe that in the world we have such type of network which needs 16 million hosts per single network. Okay, so the default approach is give us this limitation. As we discussed the limitation in the previous lecture, they will give us more number of hosts per network. This is the problem with the default approach and limited number of network addresses. Now we are going to classless approach. This is the subnetting approach. Okay, why we call it classful? Because the classful approach say that in class A there are particular number of network bits and number of host bits. Okay, like we have 7 network bits, and class A we have network bits, and we have 24 host bits. 24 means the second, third and fourth octet belongs to host. We cannot increase and decrease this number, okay, because it's classful. We must follow the class rule. Class A 24 host bits, but class, let's say now you can decrease the number of host bits. Okay, because you are no more restricted to this class limitation or rule. You can go to the second octet, you can use bits from there. You can go to third octet and fourth octet, and from there you can use the network bits as a host bits, mean the suffix bits as a prefix bit. Okay, let's do that. For example, IP address is 10.0.0. I want to borrow one single bit, and remember, in classless we are doing what? We are borrow bits from where? from the suffix. Suffix mean from the host, and use them as a prefix bits. Okay, let's suppose borrow 1 bit. So number of borrow bits is equal to 1. So when we will borrow the 1 bit, how do you know that we will borrow 1 bit? From the subnet mask. Same IP address, 255.128.0.0. So this part, this 128, say this is the borrow bit. Okay, this is what, this is the borrow bit. Okay, the value of borrow bit mean we borrow 1 bit from the second octet, from this octet, and we represent it by the subnet mask, and that's why the subnet mask is 128. If we will try to write them in a binary, so it will be like this first one, 1 2 3 4 5 6 7 8, all 8 bits are on, and here the most significant bit is borrow it, this one. And what is the value of this? Is 128. In the third octet we didn't borrow any bits, so it is what, 8. In the fourth octet we didn't borrow any bit, so it is what, the same. We only borrowed this bit, and that's why the value is what, the value is 128. And now here the total number of network bits are 9. Okay, because by default, according to the classful approach, one octet was, the first octet was the network octet. Okay, this octet was the network octet, and according to the classless approach, we come to this octet, the second octet, and we borrow bit here, and we will use them as a what, as a prefix, because we are going what, classless. And why we are doing this? We are doing this to divide the main network into subnetworks for the subnetting purpose. Okay, we already borrow 1 bit. Okay, now let's find out some values after borrowing 1 bit. Obviously we did subnetting, we borrow 1 bit, so we will have subnetworks. Let's find out number of subnetworks. To find the number of subnetworks, I will use the formula 2 power n is equal to number of subnetworks. But keep in your mind, this n mean number of borrow bits. Okay, so how many bits do we borrow? We borrow only 1 bit, so 2 power 1 is equal to 2. So we have what, 2 subnetworks. Okay, the 10 network is now divided into 2 subnetworks. And the subnet mask after the borrowing 1 bit is what, 255.128.0.0. that was the subnet mask. Okay, the number of hosts, before it was this much, now 2 power h. Okay, number of hosts per subnetwork. Remember, before we were using number of hosts per network, now we will use number of hosts per subnetwork. Okay, 2 power h minus 2. What is the h value? 2 power 23 minus 2. Before it was 24. Okay, so 24 minus 1 is equal to what, 23. Okay, this one is what, it's a borrow bit. Okay, b bit, and this was what, total bit. This is what, remaining bits in suffix. Okay, so it is equal almost 8 million something. Okay, Okay guys, this was the number of subnetworks and the number of hosts per subnetwork after borrowing only one bit. Now let's find the range of each subnetwork. Okay, it's very simple. In order to find the number of range of each subnetwork, you have to first identify from which octet we borrow bit. From the second octet we borrow a bit. How much bit we borrow? One. So the number of subnetworks is how much? The number of subnetworks is 2. What was the default range of the second octet? The default range of the second octet was this. It was 10.0.0.0 and it was up to 10.255.255.255. Focus on the second octet, because from here we borrow a bit. It is what? Equal to 256. Okay, so what is the number of subnetworks? 2. So in order to find the ranges, the simplest formula is 256 divided by 2. This is what the total range of the second octet, and this is the number of subnetworks, is equal to 128. Okay, so 128 mean what? 128 mean this, from 0 to 255, this range. Okay, from 0 to 255, it's up to 127. From here to here it's 128, and next to 128 to 255, it's equal to 128. Okay, here it's 128, it's 128, the same range. Now let's, for example, I'm going to name the subnetworks as in subnetwork 1, subnetwork 2, subnet 1. Subnet 1 is 10.0.0.0 up to 10.127.255.255. Subnetwork 2, 10.128. How do I know it's 128? Because it starts from 128.0.0, 10.255. Its range end on what? 255.255.255. Okay, if this is the very first address and this is the very last address, mostly we call it what? We call it network address. We call it broadcast address. If you want to find the first valid and the last valid, simple. Increase one here. This is the first valid, and the last valid decrease from the last one. 254, and here same. 254. So this is what? These are the ranges of each subnetwork. So you can see here, by subnetting, I divide this one single network 10 into two subnetworks, and I decrease the number of 16 million hosts per network, okay, to 8 million hosts per subnetwork. I will solve one more example. Okay, then I will end this session and I will give you some homework. Like, you are required to borrow 3 bits, 4 bits, 5 bits, up to 8 bits. You have to practice. Okay, let's come to another example. I will borrow 2 bits. So number of borrow bits is equal to 2. Now what will be the number of subnetworks? Number of subnetworks is very simple. 2 power 2 is equal to 4. So 4 are the number of subnetworks. Number of hosts per subnetwork. How to find it? Very simple. 2 power h minus 2. What is the h value? 2 power 22 minus 2 is equal to 22 comes from where? We know this that the default number of host bits was what? 24. We borrow how many bits? 2. So remaining is what? 22. Okay. So 2 power 22 minus 2 is equal to 4,194,302. See, it was 16 million, but just by borrowing some bit, it means by doing subnetting, we decrease the number of hosts from 16 million to 4 millions. Okay, what will be the subnet mask after this? Subnet mask will be 255 dot. We borrow how many bits? 2. So 64 plus 32 is equal, no, 128 plus 64 is equal to 192.0.0. Okay. If you are confused, don't be. See, we borrow what? 2 bits. It means the most significant first 2 bits are on. So what was the value of this first one? 128. What was the value of the second one? 64. So it's equal to what? It's equal to 192. Okay, so this 92 comes from here. Okay, we will plus the value of both on bits. Okay, because you know that when the bit will get on, it will carry value. Okay, and in decimal we will write that value, just like the 192 is the value of this first most significant on bits. Okay, and now let's find the number of subnetworks here. That's very simple. The octet total range was 256. Number of subnetworks is how much? 4 divided by 4 is equal to 64. Okay, so this means from 0 to 255, the main range. Now it is what? 64. So I will come to 63, and then it's finish on 63. Next we'll start on 64, 127, 128. If you are confused that okay, the next network will be start on 128, obviously because the second one is finished on 127, what will be the end value? That's very simple. What is our value? 64 plus 64. So here what? 11, 1 is here, 3 and 6, 9, and 1 is here, so 191. The next stop on what? 191, 192, and finally 255. Okay, don't forget here we have 64, 64, 64, and 64 number of ranges. Okay, this is not the number of host or not the number of networks. Okay, it's just only the range which will be assigned to each subnetwork. Okay, which will be assigned to each subnetwork. Now let's go a little down. I have 4 subnetworks, so I will name them subnetwork 1, subnetwork 2, subnetwork 1. The starting is 10.0.0.0. The end is 63.255.255. Subnetwork 2, 10.64.0.0, 10.127.255.255. Okay, don't be confused. The 0 from 0 to 63 is from here. Okay, and 64 to 127 is from there. Next, subnetwork 3, 10.128, because it's end on 127. Okay, dot 0 dot 0, end on 191.255.255. Subnetwork 4, 10.192.0.0, 10.255.255.255. If you want to find the first valid and last valid, very simple. Increase one here and decrease one at the last point. 10.64.0.1, 10.127.255.254, and here 10.128.0.1, 10.191.255.254. Same here. 255, 255, 254. Okay, dear students, so this was the 4 sub networks, and these 4 sub networks were found out here. The ranges were found out here with the help of this formula. Okay, and number of hosts is found out here. If you are confused that are these will be equal to 4 million, that's very simple. Take this one, 250. Okay, no, here is how much? 64. Here is how much? 256. And here how much? 256. So multiply this is equal to 4194,304. Okay, minus 2, it means we have to minus the first one and last one, because the first one is what? It's a network, and the last one is what? It's a broadcast address. We don't use it, we don't assign these two addresses to the computers, okay, because it will be used for the broadcasting purpose, and this will be used by the network. Thank you, dear students. If you have any question, any confusion about any of the point in this lecture, you can let me know in the comment section. I will definitely reply. Okay, and you can also let me know about any of the topic you are confused in that. Okay, I will try to make a dedicated tutorial over there. Thank you so much. See you in the next lecture. But you should solve this. This is your homework, and you will share the homework via email. Borrow bits 3, 4, 5, 6, 7, and 8. Okay, and then you have to find out number of subnetworks, host per subnetwork, subnet mask, range of each subnetwork. Okay, dears. Yeah, once you solve this, you can share me the result with my email. My email is thank you so much.